Hello everybody, it's Sean at Huddersfield New College. Going to have a look at Foundation Tier Practice Set 3 Paper 1 of AQA's Practice Material Exams. This one is a non-calculator paper, so calculators can't be used for it. If you're working at home or not in an exam condition, I suppose you can use a calculator to check your answer, or of course check this video for your answers if not. Anyway, let's have a look at the first question and get started. Question 1, we need to work out what 9/10 is as a percentage. So, first of all, it's always a good idea to remember what percentage means, and you should know by now that percentage means out of 100. By its definition, percentage means out of 100. So you can think of it as a fraction. Percentage is just a special kind of fraction with the bottom number's 100. So at the minute we've got 9 out of 10. Percentage, we want that bottom number to be 100. So what could we do to 10 to get it to be 100? What could we multiply 10 by to get it to 100? Well, we could multiply 10 by 10. 10 times 10 is 100. But if we multiply the bottom number by 10, we need to do the same to the top number. 9 times 10 is 90. So 9/10 is the same as 90 out of 100, which by the definition of percentage means 90%. And so the first question, the one we need to circle, is 90%. Again, as well, if you think about it in a different way, 9/10 is definitely more than half. Half as a percentage is 50. This is the only one which is over 50%. This is really the only one it could be. So question 1, you should find that hopefully pretty straightforward. Question 2, which of these numbers is a multiple of 12? Now, a multiple of 12 just really means a number in the 12 times table. So, if we just consider the 12 times table for a second, and then we can just see which one of these numbers pops up in the 12 times table. The first one is 12. 12 times 2 is 24. Add another 12 is 36. 48. Add another 12, we'd get 60. Add another 12, we'd get 72. Add another 12, we'd get 84. But now we've gone bigger than any of these numbers, so we don't need to go any further. So let's check which number in this list is one of the possible options we can circle. 72 is the one in the 12 times table, which is here, and so therefore we need to be circling 12 as our answer. So that's question 2 done. Question 3, which is the most frequent item in a list? Simple as this, most frequent is the mode. Mode equals most, to put it simply. Mode is most. Mean is where you add everything together, then divide by the number of things you've just added up. Median is the middle number, once you put them in order of size, and the range is the highest, take away the lowest. So most frequent is the mode. Question 4, convert 2.5 meters into centimeters. Circle your answer. We need to remember for this one, how many centimeters makes a meter? Well, 1 meter, we need to know, is 100 centimeters. This relation is in the form 1 to n. What I mean by that is, one of the numbers in this relationship is a 1, the other number is not 1. If you've got a relation between two different things in this form, where one number is 1 and the other number isn't 1, we can change from one to the other by multiplying or dividing by the number that isn't 1. So in this case, we're going to convert from meters to centimeters, or from centimeters to meters, either by multiplying or dividing by 100. From meters to centimeters, we're going from a small number, 1, to a bigger number, 100. So to go this way, we're going to multiply by 100. And if we wanted to go the opposite way round, we do the opposite thing. And so if from meters to centimeters is multiplying by 100, to go the opposite way, we have to divide by 100. In this case, we need to change from meters into centimeters. And so we do 2.5 times 100. Two ways of doing this really. We can just compare these answers so we can see which one it's going to be roughly. 2.5, well, if it were 3 for example, 3 times 100 would be 300 meters. Also as well, if it were 2 meters, 2 times 100 would be 200 meters. 2.5 is in between 2 and 3, and so we're after an answer which is between 300 and 200. So it's got to be 250 centimeters. 2.5 multiplied by 100, to do it directly, if we multiply by tens, hundreds or thousands, the number of zeros in the number tells us how many digits the decimal is going to move over. So this decimal is going to move 2 places to the right because 100 has 2 zeros in it. So it goes over the 5, then over nothing. Nothing in maths, of course, is a 0. So 2.5 times 100 would be 250.0, which of course is just 250. At any rate, we need to circle 250 centimeters. Question 5. A two-step calculation, a plus and a minus. What I'd suggest first is we can add these two first. If you're thinking about bid maths, or bod maths as your teacher might say, you might think, well, you have to add anyway before you subtract. Well, adding and subtracting can be done interchangeably. As long as you add and subtract after you've divided, multiplied, done your brackets and powers, you can add and subtract in any order you like. But in this case, let's just do it in order. So 7152 plus 876. So if we just add these together, 2 plus 6 is 8, 5 plus 7 is 12, carry the 1 over, then we've got 1 plus 8 is 9, plus the 1 we've carried is 10. So again, put the 0, carry another 1 over, and finally 7 plus this final carried 1 is 8. And so 7152 plus 876 is 8028. Now we can do 8028 subtract 139. So 8 take away 9 we can't do using this method, and so we need to borrow 1 from the 2. If we borrow 1 from the 2, 2 becomes a 1, and the 1 we've borrowed goes next to the 8. So that 8 is now 18. 18 take away 9 is 9. 1 take away 3. Again, we can't do that because 3 is a bigger number than 1. So we need to borrow from next door, but we can't do that because there's nothing next door. And so we need to go right to the end, to the 8. If we borrow 1 from the 8, that becomes 7. But now we move the numbers over 1 digit at a time. So we don't put the 1 we've borrowed over the 0, we go to the 0 first. So if 1 we borrow from the 7 goes next to this 0. So now there is something next to this 1, that's because that 0 is now a 10. So now if we borrow 1 from that 10, as it now is, 10 take away 1 is 9, and the 1 we've borrowed goes next to this 1 now. So that 1 is now 1, 1, 11. 11 take away 3, we can do this now. 11 take away 3 is 8. 9 take away 1 is 8. 7 take away nothing beneath it is just 7. And so the final answer for question 5 is 7, 8, 8, 9. Question 6, we've got some times to be working out. The first part of the show starts at 7:45 and it lasts 35 minutes. What time does the first part end? So, if we start at 7:45, how long will it be until we get to 8 o'clock? Well, from 7:45 till 8 o'clock is 15 minutes. But of course, this show, the first part of the show is going to last 35 minutes. And so the first 15 minutes will take us to 8 o'clock. After the first 15 minutes, though, there'd still be another 20 minutes left to go. And so after 15 minutes, we go to 8 o'clock. The next 20 minutes will take us to 20 past 8. So the first part will end at 8:20 p.m. Part B. After the first part, there's a 20-minute break, and the second part lasts 45 minutes. What time does the second part end? So if there's a 20-minute break and the second part lasts 45 minutes, that's going to be a total, including the break, of 65 minutes. Now, in an hour, there's 60 minutes, so 65 minutes is 1 hour and 5 extra minutes. And so if we just remind ourselves from part A, when the first part ended at 8:20. So if the first part ended at 8:20, we now need to be thinking about when the second part ends. You could do it piece by piece if you wanted to, so you could think of it as the break. The break's 20 minutes. 8:20 plus 20, it'd be 8:40. And then from 8:40, another 45 minutes, that'll take you to 9:25 p.m. But again, as I initially suggested, it might be easy just to consider these two together, the break and the second part, as 1 hour and 5 minutes. Because if you were to do that, you can do it in one go. From 8:20 all the way to the end, we can just add on 1 hour and 5 minutes. 8:20 plus 1 hour would be 9:20, plus an extra 5 minutes would be 9:25. So whichever way you do it, you should find that the second part ends at 9:25 p.m. Question 7. A game is played with a fair spinner. The player spins the spinner twice, and the player adds the two numbers to get the score. So first of all, you need to complete this table to show the possible scores. So all we're doing here is adding the top row to the row at the side. So each time we're just adding these two numbers. So first of all, 8 plus 8, it'd be 16. This one here, 17 plus 8, that'd be 25. This one, 32 plus 8, would be 40. 8 plus 17, 25. 17 plus 17. 17 times 2 is 34, and 17 plus 32 would be 49. And the last row would be 40, 49, and the last one 64. And part B, we need to work out the probability that the score is a square number. So we need to just remind ourselves what square numbers are. Square numbers are numbers we get if we take a whole number and multiply it by itself. So the first square number is 1 times 1, which is 1. The second square number, 2 times 2, which is 4. 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. And just keep going on. 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. They'd go on forever, but we don't need to go beyond 64 even, because 64 is the biggest number in this list of combinations. And so, which ones above are square numbers we have in this list? And so, in this list, we can see 25's come up. We can see that 49's come up. 49's come up twice, in fact. And also, 64 has come up once. Apologies, I must be tired. 25's come up twice. And also 16 too. I missed 2 there, that's quite bad. Anyway, got them eventually. So, if the others aren't square numbers, there's 6 here out of 9 combinations that are square numbers. So if 6 out of 9 combinations of square numbers, we can write this as a fractional probability. If 6 out of 9 are square numbers, then we can write this down as 6 over 9. 6 out of 9, which if we want to, we can simplify down to 2/3. But if it's a probability question, you don't have to simplify down the fraction, which is one of the benefits of doing a probability question. So our answer is 6 out of 9, or if you do want to simplify it down, would be 2/3. So that's question 7 complete. Question 8, we've got a stacked bar chart here where we've got information about basketball teams. So we've got Bristol, Leeds, Manchester, Plymouth and Surrey, both home wins and away wins. And for part A, we need to work out which team had the most home wins. And so home wins is represented by the black bar, so it's whichever team has the tallest bit of a bar that's black. And so hopefully we can see fairly clearly that's Manchester. And so which team have the most home wins? The answer to that will be Manchester. And part B, which 2 teams had the same number of away wins? So the away wins are given by this greyish coloured bar. And so if you have a look for Bristol, this bit's here 7, and this bit here's 13. So 13 take away 7, Bristol had 6. Leeds, here's 4, and it goes up to 9. So 9 take away 4, Leeds had 5. Manchester, from 8 up to 12, we had 4 away wins. Plymouth, this bit here is 5, and it goes up to 11. So from 5 to 11 is 6. And finally Surrey, that's just 1 away win. So for teams that have the same number of away wins, we can see that it's Bristol and Plymouth, because Bristol and Plymouth both had 6 away wins. So for the answer line for part B, just need to write down that it's Bristol and Plymouth. And for part C, it says how many more home wins than away wins were there altogether. And so what I'm going to do is just copy down what we had from part A and B, these figures here, 6, 5, 4, 6, 1. And we're going to do the same for the home wins as well. So for Bristol, there were 7 home wins. For Leeds, there were 4. Manchester had 8 home wins. Plymouth had 5. And Surrey had 4. So what we can do is total up here for home wins and compare these to the away wins. So the home wins, we had 7 plus 4 plus 8 plus 5 plus 4. So home wins, 7 plus 4 is 11. 11 plus 8 is 19. 19 plus 5 is 24. Plus a final 4 gives us 28. And the away wins, 6, 5, 4, 6 and 1. I'm just getting these figures here from these blue numbers. 6 add 5 is 11, plus 4 is 15, plus 6 is 21, and finally plus 1 gives us 22. So home wins comes to a total of 28, and the away wins 22. So the difference between these will tell us how many more home wins there were than away wins. So the final step now is just to do 28 take away 22, which gives us a total of 6. So there are 6 more home wins compared to away wins. Question 9. Solve x plus 12 equals 29. This is a one-step equation. To solve it, we need to have x on its own. At the minute, we've got about 12 in the way. That 12 is positive. If we put it to the other side of the equation, if we swap the side, we swap the sign. Opposite of plus 12 is minus 12. So x will be 29 minus 12, which will be 17. You can just do these by inspection as well sometimes, just by looking. What number, then you add 12 to it, gives you 29. Well, 17 plus 12 is 29. So x has got to be 17 to make this one work. So for part A, x equals 17. For part B, we've got 0.5 y equals 20. That 0.5 is multiplying the y, because it doesn't say what it's doing. And if you've got two things next to each other in algebra with no mathematical instruction noted, it always means one thing multiplied by the other. And so if we move that 0.5 to the other side, once again we swap the side, then swap the sign. Opposite of multiplying by 0.5 is dividing by 0.5. And so y will equal 20 divided by 0.5. Now there's two ways you can think about this. One way is we can think of this in terms of what division means, and also in terms of money. 0.5 means 0.50. And division is often used for seeing how many times a smaller value fits inside a bigger value. So we can picture this in terms of money. That could be £20. This could be 50p. How many 50p's would you need to have £20 altogether? Well, two 50p's makes £1, and so £20 will be 20 lots of two 50p's. And 20 times 2 would be 40. So y will equal 40. A different way you could think of this would be to write 20 divided by 0.5 like this. Remember, a fraction is just how you could write a division. Top divide by bottom. Dividing with decimals seems harder, so what we could do is just get rid of the decimal and make it into a whole number by multiplying 0.5 by something. The easiest thing I'd suggest to multiply 0.5 by would be to multiply by 2. 0.5 means half in decimal form. So if we do 0.5 times 2, that would give us one whole. Two halves make a whole. But if you multiply the bottom by 2, we'll need to do the same to the top. So 20 times 2 gives us 40. Then 40 over 1, 40 divided by 1, obviously is just 40. So whichever way we do it, we should find that y equals 40. Question 10, we've got boxes which cost £2.40 each, and we need to work out the cost of 3 boxes. And so 3 boxes we can think of as being 1 box added to 2 boxes. 1 box plus 2 boxes gives us 3. And so we have information here ready for us, we just need to add up these two values. And so £2.40 added to £4.80. We can do just using column addition. 0 plus 0 is 0. 4 plus 8 gives us 12. So we can put the 2 down, make sure the decimals line up by the way. And the 1 in 12 we carry on to the next column. And finally we've got 2 plus 4, which is 6, plus the carried 1 gives us 7. And so the cost of 3 boxes comes to £7.20. Part B, Ethan pays £52.80 for some of these boxes. Work out how many boxes he buys. So we could build up to £52.80 using the information we have here. A second method I'll show you is how you can do it directly using division. But what I'd suggest first of all is look at 10 boxes. 10 boxes costs £24. So if 10 boxes are £24, we could multiply this by 2. 20 boxes, twice as many, will cost twice the price. 20 boxes would be £48. All I've done here is just multiplied the number of boxes by 2 and therefore multiplied the price by 2. 20 boxes is £48, but Ethan spends £52.80. So this is only £48. To go from £48 to £52.80, that's an extra £4.80. And so how many boxes would be £4.80? Because 48 plus £4.80 would give us a total of £52.80. So from this table we can see that 2 boxes would be £4.80. So £52.80 is the total of £4.80 plus £48, and in terms of boxes, that's 20 boxes plus 2, and 20 plus 2 means 22 boxes. So the answer in terms of how many boxes he buys is 22. I did mention I'd show you a way using division. We could work out the number of boxes he buys by taking the amount Ethan spends, £52.80, and dividing that by the cost per box, which is £2.40. So if we set this out as a fraction, and then look to eliminate the decimals, both these numbers here have 2 decimal places, and so what we can do in effect is get rid of these decimals by multiplying the top and the bottom by 100. And if we did that, we get 5280 on the top and 240 on the bottom. Both these numbers are now whole numbers, and both these numbers end in a 0, so we could simplify both slightly by taking a 0 off each number, which should give us 528 over 24. Both these numbers are even numbers. Even numbers can be halved, so we could divide both these by 2. I think this is a harder method personally than just using this method, but I'm just showing you just in case you'd like to use it or in case you want to know. 24 divided by 2 is 12. Now half of 28 is 14 and half of 500 is 250, and so half of this number here would be 264. Both numbers are still even, so again we can divide both top and bottom by 2 once again. And eventually what you'll find is you'll get a fraction which should be easy enough that you can do the division of it comfortably enough. 12 divided by 2 is 6. 264 divided by 2 would be 132. And it should be about this time where you're thinking, actually, yeah, I can do 132 divided by 6. Just by using the bus stop method, for example. 6 into 1 doesn't go, and so this 1 carries over to the 3 as a remainder. 6 into 13 goes twice. 2 6s are 12, which is 1 away from 13, so again the remainder is 1. Then finally 6s into 12 goes twice with no remainder so we can stop. So using this, in my opinion, harder method, we'd get 22 boxes in the same way. Part C, it says use a table to write £9.60 to 12 as a ratio in its simplest form. And so £12 is 5 boxes. And here, £4.80 is 2 boxes. You can probably notice, I'm hoping you can notice, that double £4.80 would be £9.60. And so if we double the price, that must be double the number of boxes. So £9.60 would be 4 boxes worth. And so the ratio here, simplified down, would be 4 to 5. And that's question 10 complete. Question 11, we're asked how many degrees does the hour hand on a clock turn in 9 hours? For this question, I reckon it might be easier just to actually draw a clock. In fact, draw 2 clocks. So the first one I've got, just for ease, is 12 o'clock. Now imagine that 9 hours later it's 9 o'clock. So the hour hand is the smaller hand on a clock. So the hour hand is going to be this one here. So you can just see it at 12, it's pointing at 12. So in 9 hours what's going to happen is it's going to turn from facing 12 all the way around to 9. So whether it be from 3 o'clock to 12 o'clock or from 1 o'clock to 10, it'll always be the same amount of turn. So in this case, just picking from 12 o'clock to 9 o'clock, because in my head it seems most straightforward, it will have turned through this section here, this green section, is what it will have turned through. And so imagining it as a circle, this green section here is 3/4 of a turn. And so it will have turned through 3/4 of a full 360. So half a circle, half a turn would be 180. A quarter would be half of 180, which would be 90. So if 1/4 is 90, then 3/4 would be 90 times 3, which should be 270 degrees. And so the option we need to circle for question 11 is 270 degrees. Question 12, I'll do this in two different ways. By the way, it says what fraction of 1 1/4 is 1/8? Now we can embed these fractions into another fraction. Whatever value comes after the word of goes on the bottom of the fraction. And so we can compare these two as a fraction by putting 1/8 on top and then 1 1/4 on the bottom, because it says of 1 1/4. And so what we could do is change this 1 1/4 into a top-heavy fraction. So leave 1/8 as it is. That means 1/8 divided by, now 1 1/4, 1 times 4 is 4, plus 1 is 5. And so 1/8 as a fraction of 1 1/4 is the same as 1/8 divided by 5/4. Top divided by bottom. Now, if we're doing one fraction divided by another, remember the rule. We keep, we change, we flip. A bit like KFC. We keep the first fraction as it is, we change the divide symbol to a multiply, and we flip the last fraction on its head. So 5/4 becomes 4/5. Now when we multiply fractions, we just multiply the tops together and multiply the bottoms together. So 1 times 4 is 4, 8 times 5 is 40, and then simplify it down if we can, which we can. 4/40 will simplify down to 1/10, because we can divide both the top and the bottom by 4. And so this answer here would be 1/10, so that's all we need to circle. Now we can do this in terms of pictures as well. So doing it as pictures, as long as you can draw it accurately and visualize, the picture method I'm going to show you now I think is somewhat easier. So what I've done here is I've drawn 1 1/4. So there's one whole circle, and 1/4 of a circle. So that's 1 1/4. Now 1/8, an eighth is actually half of a quarter. And so we can picture 1/8 like this. 1/8 is that green section, which is the same as half of a quarter. This was a quarter, which we've just halved to get 1/8. So how many eighths, how many of these green pieces would fit in to this 1 1/4? How many greens would make all of this yellow shape here? And so what you've noticed and what I've said is that an eighth is half of a quarter. And so if I split this quarter into eighths, we get 1 and 2. And now if I split each of these quarters of the whole circle into eighths, what we should find is, in total, there's 10 eighths in 1 1/4. That's 1, 2, 3, 4, 5, 6, 7, 8 eighths in a whole, 9, 10. So in total there's 10 eighths. And so this piece here represents just one piece out of a total of the 10 eighths which we'd have in 1 1/4. And so again we'd get 1 over 10. Question 13. We've got a point on a graph and the equation of this graph is y equals x squared plus x. We're told that the x coordinate of a point is -3. And so we now need to work out the coordinates of a point. So we're told that x is -3. So if one we need to circle, it needs to have x as -3. So it's going to be one of these, which helps not at all really, because we all start with -3. That's where the -3 comes from. So here what we have though is a recipe for working out what y is for any value of x we might want. And so when x is -3, y will be x squared, which is -3, all of that squared, plus -3. -3 squared means -3 multiplied by -3. Now if we multiply a minus by a minus, we get a positive outcome. So -3 all squared is actually +9. And if we have a plus and a minus next to each other, or a minus and a plus, we can replace the different symbols with a minus. Mixed makes minus, as Matthew Knight once told me. A plus and a minus makes a minus. And so that's the same as 9 minus 3, which of course will be 6. So when x is -3, y is 6. So the coordinates are -3 and 6. So the only one it could be is this third one here. So for question 13, we need to circle that the point will be -3 and 6. Question 14. Is 30 multiplied by 445 greater than 15 multiplied by 900? It's a 2-mark question, so be thinking maybe there's an easier way of doing it than just multiplying these numbers out. 2 marks to do 2 hard multiplications would be quite stingy. So let's just compare the numbers. First of all, we've got 30 and 15. 30 is double what 15 is. Okay, so this one's twice as big. We'll compare these two here, 445 and 900. Half of 900 is 450. But 445 is less than half. And so 30 times 445 is going to be less than this one here. So is it greater? No, it isn't. A reason we could give is that 30 is double 15. But 445 is less than half of 900. Something along those lines would get you marks. You could say equally 30 is double 15, but 900 is more than double 445. That might have been a nicer way of putting it. Now, in case you don't really like questions where you need to give reasons or you're not sure how to word an explanation, you could, if you wanted, and I would recommend this only as a last resort, you could just multiply them out. It'd be not a very efficient use of time, but getting 2 marks slowly is better than getting 0 marks quickly. So first of all, let's do this one. 445 multiplied by 30. I'm not going to show you all the different ways of multiplying. I'm just going to show you just this lattice method. You can use any method you want to, obviously. But all I'm trying to show you here is that you should get that this one here is less than this one. So we split the boxes going diagonally down. And we multiply what's above each box by what's to the side. So first of all, 5 multiplied by 3 is 15. 4 times 3 is 12. 4 times 3 is 12. And anything multiplied by 0 is just 0. We will now add them up going diagonally down. So first of all, that's a 0. 5 plus 0 is just 5. 1 plus 2 is 3. These zeros don't make any difference, that's 3. 1 plus 2 plus 0 is 3. And finally 1. And so the first one, 30 multiplied by 445, is 13,350. Now if we try 15 multiplied by 900, just using the same method, we should find that 15 multiplied by 900 is actually bigger. So again, of course, anything multiplied by 0 is just 0, so these columns are very easy to fill in. Just fill them all up with zeros. 9 times 1 is just 9. 9 times 5 is 45. So first number is 0. 0, 0, 0 is 0. 0, 0, 0 and a 5 is 5. 9 plus 4 is 13. So that's the answer to 15 times 900. 13,500. Now 13,500 is bigger than 13,350. It's 150 bigger, to be precise. But by doing it the long way, it would take more time definitely, but at least then you'd be able to see without any doubt that 30 times 445 is not bigger than this one over here. Question 15. Rearrange this so that R is a subject. When R is a subject, all it means is that R comes first in the equation. So it means R equals whatever. Whatever comes first is a subject. So in this case here, as it stands, P is a subject. What we want is R on its own and R first in this equation. So we want R on its own. This positive 3 is in the way. We can get rid of this plus 3 by moving it to the other side of the equation. But if we swap side, we swap sign. Opposite of plus is minus. And so on the left hand side, we then have P minus 3 equals R. So we've done the hard work, but it needs to be R written first. So R equals P minus 3. R has to be written first if R is a subject. And so the form we want it in is that R equals P minus 3. And so the one we need to circle here is the second option. Question 16, part A. Work out a quarter plus 7/10. Give your answer as a fraction. So I'll give you a standard way, and then I'll give you a way which you need to think a bit harder, but could save you time. So 1/4 plus 7/10. When adding or subtracting fractions, what we can do is cross multiply. So we replace the plus with a big times sign, if you like. And finally, the bottom numbers we multiply together. That's just a surefire way of getting the same bottom number. So if we just cross multiply here, 1 times 10 gives us 10. And the bottom numbers multiplied together, 4 multiplied by 10 will give us 40. And so we get 10 out of 40 first of all, plus, and now what we need to work out is 7 multiplied by 4. And 7 multiplied by 4 is 28. Now the bottom numbers are both 40. Once the bottom numbers are the same, we can leave them as the same. So leave them as 40 and just add the tops. 10 plus 28 is 38. The final step now, if we can simplify, we do. 38 and 40 are both even numbers, which means we can divide both of them by 2. If we divide 40 by 2, we get 20. And 38 divided by 2 gives us 19. And so the answer to part A is 19 over 20. I'll just show you another way, as I mentioned. As long as the bottom numbers of the fractions are the same, we don't have to use this way. This is my favourite way because it will always work and requires little thought. But here, is any other way we could have got 4 and 10 to be the same number? We can do this by just thinking of what's the lowest common multiple of 4 and 10. So think of a 4 times table. 12, 16, 20, and so on. And the 10 times table goes 10, 20, 30, and so on. And so what you should spot here is that 20 is the lowest common multiple of both 4 and 10. And so what we could have done as a separate option, just section this off so I'm not getting it confused with what I've done before, we could have got both of these numbers to become 20. So how many 4s make 20? 1, 2, 3, 4, 5. So what we could have done is multiplied the 4 by 5, but if we do that to the 4, we need to do the same to the top number. So we need to multiply the 1 by 5 as well. And how many 10s make 20? Well, that's just 10 times 2. So what we need to do to this fraction here is multiply top and bottom by 2. And what we get after that, 1/4 would change how it looks. 1 times 5 is 5. 4 times 5 is 20. And 7 over 10th would change how it looks. 7 times 2 is 14. And 10 times 2 is 20. Then we just add the top numbers together. 5 plus 14 will be 19 over 20. With no simplifying left to do. So same answer, different method. Part B, work out 3/5 multiplied by 7 over 2, give your answers a mixed number. So if we're multiplying two fractions together, the process is pretty straightforward. All you do, multiply the tops, multiply the bottoms. And so 3 times 7, and the bottom, 5 times 2. So that's all you really do. Look for tops, top times tops, look at the bottoms, bottom times bottom. 3 times 7 is 21, 5 times 2 is 10. That's 1 mark. We need to change it to a mixed number. And the way we change from a top-heavy fraction to a mixed number is we see how many times can we fit the bottom number inside the top. So how many 10s can we fit into 21? Well, 10 fits into 21 twice, with 1 left over. The remainder tells us how many tenths we have left over. So we've got 1/10 remaining. So 21 over 10 is the same as 2 1/10. And so that's the answer for 16 part B. Question 17, we've got a shopkeeper who uses a formula to work out the cost of bags of oranges. So the cost is just going to be 1.8 multiplied by the number of bags. We've got two different things next to each other using algebra. Now if there's two things next to each other with no instruction telling us what to do, it will always mean 1 multiplied by the other. And so this means 1.8 multiplied by n. And so work out the cost of 7 bags is what we need to do. So the cost of 7 bags is going to be 1.8 multiplied by 7. Because in this case, n, the number of bags, is 7. So we're just substituting in the value of 7 in place of the letter n. So we need to work out 1.8 times 7. What I suggest we do is forget the decimal for a second and just think of it as 18 multiplied by 7. Now we can do 18 times 7 any way you like to. I'm just going to do the old-fashioned way I was taught when I was at school. First of all, we need to do 7 times 8. 7 times 8 is 56. So we put the 6 and carry 5 over. Finally, 7 times 1 is 7, plus the 5 we've carried is 100. Sorry, is 12. 7 plus 5 is 12, sorry. So that's now 126. And so 1.8 times 7 will look like 126. However, in the question, we had 1 decimal place. There's 1 number after the dot in the question. And so in the answer, we need 1 number after the dot as well. So that 6 needs to come after the decimal. And so the decimal goes here. And so it's not £12 6p, it's £12.60. 6p would be 0.06. 12.6 means £12.60. And part B, there are 4 oranges in each bag. Work out the average cost of an orange. Give your answer in pence. So if there's just 1 bag, the cost of 1 bag would be 1.8 multiplied by 1, because here we're just thinking about 1 bag of oranges. And unsurprisingly, 1.8 multiplied by 1 is just 1.8. Which in terms of money is £1.80, or 180 pence. So if there's 4 oranges in each bag, we can calculate the cost of an orange by doing the cost of 4 of them, cost of a bag, and dividing that by 4. And so if we did £1.80 divided by 4, using the bus stop method, just make sure the dots line up top and bottom. This will calculate for us the cost of 1 orange. So can we fit 4 into 1? No, we can't, because 4 is too big. And so that 1 is a remainder which carries over to the 8. This 8 is now 18. 4 into 18 goes 4 times. 4 4s are 16, so we have 2 left over. And finally, 4s into 20 goes 5 times. And so the cost of each orange will be £0.45, which in terms of pence would be 45 pence. Question 18. We have a straight line that we're told passes through the points -1, 2 and 1, 6. So I'm just going to plot these points on the grid. So -1, 2 means 1 to the left and 2 up, which is this point here. and 1, 6 is going to be the point which is 1 along and 6 up. So 1, 6 is going to be this point over here. So we're told that it's a straight line, and so because it's a straight line, we know for definite that all the other points will be on this line as well. We're going through these 2 points. And so what we can do now is just do a straight line going through both of these points. The second thing we need to think about is there was another straight line that has equation y equals x. Now y equals x just means that whatever y is, x is exactly the same thing. So for example, picking any example, if x were 6, y would also be 6. And if x were minus 6, so would y. And so the line y equals x is just going to be a straight line going from this point to that point. So both of them are going to be straight line graphs. So just going to colour code in the line y equals x in this light blue colour. So it says to work out the coordinates of a point of intersection of the 2 lines. That is just a fancy way of saying where do these 2 lines cross. And so if you have a look at this graph, you can hopefully see that they cross here at this point. Now that point is -4, -4. And so that's all we need to do. That's a point of intersection of the 2 lines. A fairly generous 4-mark question, but in terms of just following it through, there's not too much work that needs to be done for those 4 marks. Question 19. Ajit is a barber and he charges £5 for a haircut and 10% extra for hair gel. So we're told that on one day has 52 customers that have a haircut. So if he's charging £5 for a haircut and 52 customers have a haircut, that's going to be a total for those customers, just for the haircuts alone, of 52 times 5. So 52 times 5 we can do in a few different ways, but I'm just going to do it this way just for the sake of it. So 5 times 2 is 10. So put down a 0 and carry 1 across. And then finally 5 multiplied by the 5 above. 5 times 5 is 25, plus the carried 1 is 26. And so 52 times 5 is £260. And so from haircuts alone, he's going to be making 260 quid. He charges 10% extra for hair gel, is what we're told next. So 100% of the cost of a haircut, the total cost of a haircut, is going to be £5. We can work out what 10% is. To go from 100% to 10%, what can we divide 100 by to get 10? Well, the answer is we can divide 100 by 10 to get 10%. But if we do that to this side, we need to divide £5 by 10 as well. So £5 divided by 10 will be 50p. And so what he charges for hair gel, 10% extra, is 50p. So how many people ask for hair gel? Well, we're told that 16 people ask for hair gel. And so 16 people are going to pay the 50p extra for the hair gel. So 16 people paying for hair gel, and that's going to be 50p a piece. 16 50p pieces would be £8. And so the total amount that he charges customers on that day, total, is from haircuts plus what he charges for gel. So the haircuts is £260. Then you make an extra £8 from charging people for putting gel on their hair. 260 plus 8 is £268, and that's the total for what he charges customers in that day. That's question 19 complete. Question 20, we're told to estimate this calculation by rounding each number to one significant figure. So we need to show the working as well, so we can't just put down an answer on the answer line without any justification. And so one significant figure means we want to keep the first non-zero number we see in each value, and then round that first non-zero value according to the digit next to it. So it's easiest just if I do it number by number and show you this. So you've got 78, 11.6 and 391. So if we round 78 to one significant figure, the first non-zero number is obviously the 7, and so we need to round that 7. Next to it is an 8, and so that 7 is going to round up to 80. Sorry, the 7 is going to round up to 8, so the number is going to round up to 80. 11.6, again, the first non-zero number is the first 1, and so we're going to round that 1. All the other numbers are going to change to a 0 if needed. And so next to this 1 is another 1, and so we're not going to round this up to a 2, it's going to stay as a 1. The numbers next to it change to a 0. And so that's 10.0, but because 10.0 is just 10, we can leave the 0.0 out and just call it exactly 10. And the last number we need to round is the denominator, 391. So again, the first significant figure is the 3, and next to the 3 is a 9. So that 3 is going to round up to 4, and the other digits after it will change to a 0. So 391 to one significant figure is going to be 400. And so this is how the numbers have changed. And so what we're going to do now is do the calculation, but with these rounded values. When we're estimating a calculation, we don't round off at the end. We round off the values initially and then calculate with the rounded values. We estimate and then calculate. We don't calculate and then round. And so just putting these rounded values in to the initial calculation, 78 becomes 80. 11.6 becomes 10. 391 becomes 400. And so 80 times 10 is 800. 400, we can just stay as it is. 800 divided by 400. Now because both 800 and 400 are whole numbers ending in zeros, we can cancel this down easily enough by just cancelling zeros from the right, moving inwards. And so we'd have 8 over 4, which means 8 divided by 4, which of course is 2. And so our estimated answer is 2. question 21, we've got an equation to solve, and I'll show you two different ways of doing this. There's obviously more than two ways. I'm just going to show you two ways which I'd be most likely to mention if I were to be teaching you. So the first way, I'm just going to mention the idea of swapping side and swapping sign. To solve the equation, you want to end up with Vx on its own. So at the minute we've got a few things in the way. That 3 is in the way, and that 9 is in the way. The first thing we can do is to move this 9 over to the other side of the equation. And if we swap the side of the equation, we swap the sign. Swap side, swap sign. This 9 is a minus 9, so when it swaps over, it will change from a minus to the opposite sign. Opposite of minus is plus. Now on the left hand side, we'll just be left with x over 3, and on the right, 12 plus 9 is 21. The next thing we can get rid of is this 3 at the bottom, and that 3 is dividing the x. X over 3 means x divided by 3. And so if we move that 3 to the other side, swap side, swap sign. Opposite of dividing by 3 is multiplying by 3. And so x will equal 21 multiplied by 3, which will be 63. So that's our final answer. Another method, obviously you just need to do one method, you don't need to do the same question again, but just to show you a different way, what you could do is a flowchart method, and the way this works is we start with the letter we want to find, and then step by step think what happens to this letter. So the first number x interacts with is this 3, and this 3 is dividing the x. So the first thing that happens to x is it gets divided by 3. After being divided by 3, then we subtract 9, and the answer to that is 12. Now what we do is we start at the end and work backwards towards the beginning, but because we're going the opposite way this time, we do the opposite thing to above at each step along the way. Above we were subtracting 9, moving left to right. But now because we're going from right to left, instead of subtracting 9, we're going to add 9. And so at this stage, 12 plus 9 was 21. But we've still got one more step to go. Now above we were dividing by 3. Going the opposite way, we'll do the opposite thing, which is multiplying by 3. And so x will be 21 multiplied by 3, which is 63. And so finally, x we know is 63. X equals 63, like we said earlier. That's question 21 done. Question 22, we have a lucky dip stall, and players pick a ball at random from a tub and then replace it. So part A, we're asked what is the probability that Emma wins a prize with her first pick. So how are we going to win a prize? Well, it says here, pick a green ball and win a prize. So you get a prize by picking out a green ball. So let's see what we have in this tub according to the question. So we've got 250 red balls, 230 yellow, 120 green. So let's just find out the total number of balls we've got so far. 250 plus 230 plus 120 0 plus 0 plus 0 is obviously just 0. 5 plus 3 plus 2 is 10. So put the 0 for 10 and carry the 1 onto the next column. And finally, 2 plus 1 is 5, plus the 1 we've just carried is 6. So there's 600 balls in total. Emma's going to win a prize if she picks a green ball. So how many are green? We're told that 120 are green. And so as a fraction of a total, we can say that 120 out of 600 are green. So as a fraction, 120 out of 600 are green, and that relative frequency of green balls is your best estimate for the actual probability that she'd pick a green ball, and therefore win a prize. So we can actually leave the probability as it is. Probability is one of the rare things with fractions where you don't actually have to simplify down the fraction. We can just leave it as 120 over 600. Now, if you're not sure whether to simplify down or not, or you can't remember that fact, if in doubt, simplify if you can. But if you can remember, just remember that you don't have to simplify a fraction if it's a case of probability. If you wanted to simplify it down, the fully simplified answer you should arrive at is 1/5. There's a 1 in 5 chance of picking a green ball and winning a prize. For part B, with her 15 picks, she actually wins 4 prizes. Is this more or less than the expected number? We need to show the working. And so she actually wins 4 out of 15 picks. So in terms of what she actually wins, she wins 4 out of 15 times. What she expected, the best estimate for what you'd expect is the theoretical probability of how many times she'd win. And from part A, we expected that she'd win 120 out of 600, which is the same as 1/5. So she expected to win 1 out of 5. So it's a case of having to compare these fractions. Which is a bigger fraction, 1/5 or 4/15? So the best way of comparing fractions is to make sure that the bottom number, the denominator, is the same. And so we can compare the actual to what she expected to win by changing this denominator, the 5, into 15. Now 5 can be easily enough changed into 15 by multiplying it by something. So what can we multiply 5 by to get it to 15? The answer is we can just multiply 5 by 3 to get 15. But if we do that to the bottom number, we do the same thing to the top number. And so 1 times 3 is 3. And so she expected to win 1/5 the time, which is the same as saying that's the same as 3 over 15, because 3 over 15 is an equivalent fraction to 1/5. But she actually won 4 out of 15 times. So actually she won more than the expected number, because she'd expect to win 3 times out of 15. Just put this in brackets here. So she'd expect to win 3 times out of 15. If she expected to win 3 times out of 15, but actually won 4 out of 15, then obviously that's more than the expected number of times she expected to win. So the final answer, just to answer the question as it says, is she actually wins more than the expected number of times. Question 23. The air pressure in a tyre measures 7.2 bar, and air is leaking out of the tyre at the rate of 0.2 bar per day. Assume that the air continues to leak at the same rate. After how many days will the pressure measure 4.8 bar? I'm going to show you one way of doing this, which uses division. So the pressure was 7.2 bar, and it's going to go down to 4.8 bar. And so how much is the pressure going to drop? We can calculate this by doing 7.2 minus 4.8 to find out what the difference is. 2 take away 8 we can't do, so we need to borrow 1 from the 7 next door. The 7 becomes 6, and the 1 we've borrowed goes next to the 2. So that 2 now becomes 12. 12 take away 8 is 4. Make sure the decimals line up, by the way, in a line, and then put a decimal at the bottom too. And finally 6 take away 4 is 2. And so the pressure decreases by 2.4 bar. Now air's leaking out at the rate of 0.2 bar per day. And so what we can do now is 2.4 divided by 0.2 to find out how many days it takes for it to lose 2.4 bar. Now we can do this without worrying about the decimals by getting rid of them. So what we could do, 2.4 divided by 0.2, we could get rid of the decimals by multiplying both numbers by something so that the numbers become whole numbers. What I'd suggest doing is just multiplying both top and bottom by 10. If you don't like dealing with decimals, just bear with me a second. If this way isn't for you, I'll show you a second method in a couple of minutes, so stick with it. Anyway, 0.2 times 10. If we times the number by 10, the decimal moves one place to the right. And so what we'll have there is 0.2 will become 2, and 2.4 becomes 24. And then 24 divided by 2 equals 12. So we get 12 days. If, however, that method isn't for you, we can do this way here. Just making sure I've not overlapped too much. It seems like I have, but never mind. We've got a table of values here, which we can work out. I'm just speaking about it in terms of one day after the other. And so, day since the pressure was 7.2 bar, then just working out when the pressure gets to 4.8. So over here that was 10, that was 11, that was 12. So after one day, we're just going to knock off 0.2 a day. So 7.2 take away 0.2, that'd be 7.0. Take away 0.2, again it would be 6.8. And so you could do it this way, just taking away 0.2 each time until you end up with 4.8 bar. It's going down in 2s, well, going down in 0.2. So it's a fairly easy thing to keep subtracting each time. 5.8, 5.6, 5.4. After 10 days, 5.2. After 11 days, 5.0. Finally, after 12 days, take away another 0.2. We'd get 4.8, which is what the pressure does become. And so it becomes 4.8 bar after 12 days, which is what we said earlier anyway. So for part A, the answer is 12 days. And for part B of the same question, we're told that in fact the rate that the air leaks out increases each day. So what that means is the leak is getting worse. More air is leaving the tyre each and every day. So how does that affect your answer to part A? So if it would have taken 12 days if the leak was constant, if the leak increases, it won't take as long for the pressure to drop. And so in terms of how will it affect our answer to part A, the answer would be fewer days. It wouldn't take as long. Don't need to put all this detail, but just to make it clear to you. So it wouldn't take as long. To fall to 4.8 bar. It'd fall quicker if the leak was increasing. And that's all we need to put down really for question 23. Question 24, we've got questions about speed, distance and time. So what we're told here for question 24 is there are 3 different routes between 2 towns X and Y. Route A, route B, route C. The distance and average speed for each for each route is shown. Which of the 3 routes takes the longest time? We need to assume the average speeds, and we need to also show our working. So if we've been given a question relating speeds, distances, and also now we need to work out times, if we've got speed, distance and time to consider, good chances that we can use this speed, distance and time triangle. And so if we're wanting to work out the times, time is t, and so what we do is you cover up t, and whatever's left tells us what we need to do in order to work out t. And so if we cover up t for time, then we're left with d on top and s on the bottom. And so because d is on top and s is on the bottom, we know that the time is therefore distance divided by the average speed. So what we need to do now is to compare the times for each of these 3 different routes. And so we've got route A first of all, so let's have a look at that one. So for route A, the time taken will be the distance divided by the speed. Now the distance for route A is 25 miles. And the speed we're going at is 50 miles per hour. So we've got 25 over 50, which you can think of as a fraction. Now 25 over 50 would simplify down because both numbers we can divide by 5. If you kept going, it actually simplified down to half as a simplest fraction. Now because the units of time we've put in have involved hours, the units of time that will come out will also be in hours. So that half isn't half a minute or half a day, that means half an hour. So half an hour means half of 60 minutes, which will be 30 minutes. So A takes exactly half an hour if you were travelling at the average speed. We can now work out the same thing for B. So same formula, same calculation, but with different values. And so now for B, the time taken travelling along route B will be the distance along route B divided by the average speed for route B. And so 20 miles is the distance, but the average speed for B is 30 miles per hour. And so that's 20 over 30, which would simplify down to 2/3. And that means obviously 2/3 of an hour. So let's just think about that for a second. 2/3 of an hour, how many minutes would that be? Well, an hour is 60 minutes. And so 2/3 of an hour means 2/3 of 60. We can work out what 1/3 of 60 is by dividing it by 3. But we don't want just 1/3, we want 2/3. And so after dividing by 3 to find 1/3, we need to multiply by 2 to find 2/3. 60 divided by 3 would be 20, so 1/3 of an hour is 20 minutes. Then multiply by 2, 2/3 will be 20 times 2, which is 40 minutes. And so for root B, it'll take 40 minutes. 2/3 of an hour equals 40 minutes. I'm just highlighting this up here so you can see that this relates to root B. Finally, root C. 30 miles at 40 miles per hour. So we're going to calculate the time taken if we've travelled along route C now. So once again, the time will be the distance travelled divided by the average speed. Now for C, that would be 30 miles, and the speed we've been going at would be 40 miles per hour. So 30 divided by 40. Now both of these are multiples of 10, so that would simplify down to 3/4. So because again the units of time will be in hours, that means 3/4 of an hour. Now quarters of hours is a time frame we're more used to. For example, if you're going to be 1/4 of an hour late, a 1/4 of an hour means 15 minutes. So 1/4 of an hour would mean 15 minutes. So 3/4 would be 3 times as long. 3 times 15 would be 45 minutes. And so the original question, part A, which of these 3 routes takes the longest time? It would actually be route C, because 45 minutes is longer than 40 minutes for B and longer than half an hour for A. And so the final answer for which route takes the longest would be route C. And so that's the one we need to write down on the answer line. Now for part B, we're told that John and Matt take the same time to travel from X to Y. And so John travels along route B 10 miles per hour faster than the average speed. And so if we just think about where John's going now, he's going along route B. And so route B is this middle path. So John's route will take him along here. Whereas Matt travels along route C. Now route C is the path along the bottom. So route C is this one down here. And the question we need to answer is, does Matt travel faster or slower than the average speed for route C, and by how much? And we need to show our working. Well, first of all, let's have a look what we're told about John. He's going to travel along route B, but it's going to be 10 miles per hour faster than the average speed. And so the average speed for route B is 30 miles per hour. And so if he's going 10 miles per hour faster than that, he'll be travelling not at 30 miles per hour, but he'll be travelling at 40 miles per hour. So 30 plus 10. Whoops, wrong pattern again. Here we go. 30 plus 10 would be 40. So we're adding 10 because we're told that it goes 10 miles per hour faster than the average speed. And so John, he's going 20 miles because he's going along route B, but he's actually travelling at 40 miles per hour. And so for John, using the same formula as we did for part A, the time he'd take will be the distance travelled divided by the speed. Now the distance is going to be 20 miles per hour. This time, because he's going 10 miles per hour faster than the average speed, he's going at 40 miles per hour. 20 over 40 would simplify down to a half. And because obviously the time is in hours initially, this half here means half an hour. And so John takes 30 minutes travelling along route B. Whereas Matt, going along route C, we need to now think if he travels faster or slower than the average speed. Now we're told that they take the same time, and so we know now that Matt must take 30 minutes as well. So he's also going to take 30 minutes. And Matt's travelling 30 miles. So what we need to work out here, we know the distance he's travelling, we know the time it's going to take him. If we know the distance and the time, we need to work out Matt's speed. And so if I just take you back to the formula triangle in part A for a second, we can work out speed by covering up speed. It's going to be distance divided by time. So for Matt, the speed he's going to be travelling at will be the distance divided by the time. Now the distance for route C is 30. Now the time we've got here is 30 minutes. So just be careful, this isn't hours, this is now minutes. So if we're putting minutes in, we'll get a unit involving minutes out. 30 divided by 30, any number divided by itself is 1. So that's going to be 1 mile per minute. Not mile per hour, but 1 mile per minute. So if every minute he travels a mile, how many miles would he travel in an hour? An hour is going to be 60 minutes. So if he goes 1 mile each of those minutes, in 60 minutes, he'd go 60 miles. Essentially, to change from minutes to hours, we can just multiply by 60. So Matt goes at 60 miles per hour. So just going back and reading the initial question, does he travel faster or slower than the average speed for route C? Well, the average speed for route C, we're told, because average speed is shown, is 40 miles per hour. So he's going faster, because 60 miles an hour is definitely faster than 40 miles per hour. So he's travelling faster, and by how much? Well, from 40 to 60 is an increase of 20 miles per hour. If he's travelling at 60 miles per hour, that's 20 miles per hour faster than 40. 60 minus 40 is 20. And so he's going faster, tick that box, by 20 miles per hour. Question 25. We've got a Fibonacci type sequence, and fortunately we're told what it means for a sequence to be a Fibonacci type sequence. We're told here each term is the sum of the previous two terms. You might not be told that in the exam, so that is something you may well be asked You might well need to know that in a test. And so each term is the sum of the previous two terms. And so just bear that in mind. That's what Fibonacci sequence is. You add up the previous two numbers to get the next one. So we need to show that the first term is 2. And so what we're going to be doing here is actually working backwards. And so if we were to do this, the next term back would be this one here, in front of a 28. And so using this rule here, that each term is the sum of the previous two terms, 43 will have been arrived at by adding this yellow number to 28. And so we can work out now what this term must have been. So just considering 43 would have been the yellow number plus the number highlighted in green, which we know is 28. So you can work out what the yellow number is by just rearranging this equation. This 28 is positive, so if we swap it to the other side, we'll swap the sign. Opposite of plus is minus. And so the yellow one in front of it will be 43 take away 28. If you work that out, you should find that's 15. So this number here will be 15. Now going one number back again. Now look at 28. We got 28 by adding the two terms before 28. So 28 must have been arrived at by adding this blue one to the yellow one. Just using the rule of Fibonacci. So 28 equals this blue number plus 15. And so again we can rearrange this equation, or we can just think about what number, when you add it to 15, would give you 28. The answer to that's got to be 13, because 13 plus 15 is 28. In terms of thinking of it as an equation to rearrange, we want to find this blue number on its own without this 15 in the way. So if we swap this 15 to the other side, swap side, swap sign. This 15 is positive, opposite of positive is negative, and 28 minus 15 would be 13. Finally, if we just go one number back again, we'll be at the first number, the first term. And so now, if we have a look at 15, 15 must have been this number here plus this number. 15 is the sum of the two numbers before it. So now just thinking of 15, the number 15 must be the first term, which I've just highlighted in this purple, plus the second term, which we worked out before was 13. And so what number plus 13 is 15? Obviously it's got to be 2. Again, thinking of it in terms of equations, we don't want that 13 in the way, and that 13 is positive. If we swap the side, we swap the sign. Opposite of plus is minus. So therefore the first term will be 15 minus 13, which is 2, which is what we wanted to prove all along. And so that's for working out. So the first term must have been 2. Part B, we've got a different type of Fibonacci type sequence now, but this time it's in terms of algebra. So once again, each term is the sum of the previous two terms, and we need to work out an expression in terms of A and B for the fifth term. So what we need to work out first of all, if this is the first and third term, we need to work out the second term here. B is these two terms added together. So B equals A, which is the first term, plus the second term. So we can work out what the second term is. We want the second term on its own. So if we just get the a to move away from it, so we've got the yellow thing on its own, that a as it stands is a positive thing. And so if we move it to the other side of the equation, we'll swap its side and swap its sign. Opposite of a positive a is a minus a. So the second term, for one I've called in yellow, must be the b we had minus this a. So the second term, one in the middle, is b minus a. The third term we've been given, which is b, we can now work out the fourth term. And so this fourth term is obviously going to be the sum of the two terms before it. So this one here is going to be b minus a, which is this one here, plus the third term, which is b. So b minus a plus b, we can simplify this because we've got two lots of b's. We've got b plus an extra b, which is 2b, then of course 1 minus a. So the green term, the fourth term, must be 2b minus a. Now finally, we can work out the fifth term. So the fifth term, once again, just following the law of Fibonacci sequences, this one will be the sum of the two terms before it. So the two terms before the purple one were the blue one, which is b, plus the green term, which we just worked out before, was 2b minus a. So again, if we just simplify this in terms of algebra, b plus 2b gives us 3b's, and minus a is just minus a. And so the final term we need to work out, the fifth term, is 3b minus a. So in terms of a and b, the fifth term is just simply 3b minus a. And that's all we need to do for question 25. Question 26, we've got a parallelogram and we're told that AB equals AC. AB is a side of this triangle, means from A to B, and so if this side is the same as this side, it means that two sides of this triangle are the same, and if that happens in a triangle where two sides are the same, we can say that the two base angles are the same as well. So what it means is this triangle here will be isosceles. By base angles, I mean the angles at the bottom of a triangle. Where the two equal sides meet at A, that's the odd angle out. The other two at the bottom are the same. And so the angle at B and the angle at C will be equal. Now, as well, what it's good to know is about the angles in a parallelogram. And in any parallelogram, the opposite corners are of equal sides. And so I'm just going to write that down because it's definitely worth knowing and comes up time and time again. And so in any parallelogram, the opposite corners are the same size. That's always true for any parallelogram. And so that fact here is going to help us because we know that the angle at E is 65 because we've been told it. And so if E is 65, the corner opposite E will also be 65. Opposite to E is B, and so we know this one's 65 degrees. And also, because we just said that triangle ABC is going to be isosceles, we know that the angle at C will also be the same. And so all three of these angles will be 65 degrees. And the main thing is, because AB is AC, we know that was an isosceles triangle. So I'm just going to remind us of that up here. Now, we do also know another angle. We've been told that the angle at D here is 72 degrees. And so, if we know two angles inside a triangle, we can work out the third one, because angles inside a triangle will always add up to 180 degrees. So if this one's 72, we can work out the top angle. This one here. So using facts of angles, we can say that 65 plus 72 plus the blue angle equals 180 degrees. Just using the fact that angles inside a triangle add up to 180. Now what we can do is neaten this up a bit, and so 65 plus 72, if we add these two values up, what we'd get is a total of 137. So 137 plus whatever the blue angle is, one I've coloured in blue, will equal 180 degrees. This is an equation which we can solve relatively easily. We want to have that blue angle on its own, so we need to get rid of this 137. And so by taking away 137 from both sides, or by thinking of it in terms of we can swap the side and swap the sign, we can work out this blue angle, because it's going to just be 180 minus 137. So let's just work this one out. 180 take away 137. Show you how to work it out if you're not sure. The 0 take away 7 we can't do, so we'd borrow 1 from the 8, which becomes 7, and the 1 we borrow moves to the right, so that 0 is now a 10. 10 take away 7 we can do, which is 3. 7 take away 3 is 4. 1 take away 1 is nothing. And so we've just worked out that the blue angle must be 43 degrees. And so we can fill this in. Now there is another angle fact as well we can use, and that's the fact that alternate angles are equal. By alternate angles, it's angles which look like a Z. And so if I just draw your attention to this bottom angle here, this bottom edge from halfway along BC to C, then imagine a line going up the side of the triangle, and then another line going across like this. These two sides, the top and bottom of the parallelogram, are parallel, because it is a parallelogram. And so we can use the fact that this one here will be the same as this angle here. So because this one's 65, the opposite corner of the Z, the whole corner, not just the X or the blue, but the whole thing will also be equal to 65 degrees. So this angle here, which is made up of the blue one plus x, the whole thing is going to be 65 degrees. But this angle is made up, as I say, of blue plus angle x. And so what we can say is that this yellow angle here, the 65 degree angle, will be the same as 43 plus x. Because this one plus this one here gives us the total yellow angle, which is 65. Then all we need to do is rearrange this equation so that x is on its own. So we need to subtract 43 from both sides, or like I said before, we can think of this 43 as moving side, but when we swap the side, we swap the sign. This 43 right now is a positive, so we move it across, it'll change from positive to a negative. And so x will be 65 minus 43, which will be 22 degrees, which is what we wanted to prove all along. And that's the question done. Question 27. This is very much Pythagoras, but an example done for us. So Noah is attempting to work out the base of different right-angled triangles. And so I've been given a diagram here. This side's x, this side here is y. So he's got a method for working out the base when y is 10 and x is 6. And so we just have a look at the method. 10 squared is 100. This side squared is 36. And then 100 take away 36 is 64. And finally square root 64, which would be 8. And so in this case that Noah's used, the base would be 8, which is a whole number. We need to take a statement to say that will it always be a whole number? Will the method sometimes give a whole number? Or will it never give an answer which is a whole number? Well, it can't be this last option, because the example Noah's used gives a whole number. So we know it's going to be a whole number at least some of the time, because of what Noah's just worked out here. The square root of 64 is a whole number. So it's a case of, is it this top box we tick, or the middle one? Now in terms of showing working to supporters, to think this through, what we could do is think of different numbers for x and y. So I've just copied down this triangle so we can think of different numbers. But hopefully, if you've revised Pythagoras, you should be familiar with the idea that the base can be any value whatsoever, any positive value whatsoever when it's Pythagoras. Sometimes it's a whole number, but often, in fact most of the time, it'll be a decimal answer. And so all we need to do is just think of any two different values of x and y. So pick any two different values for x and y. And what I'm going to suggest is picking easiest numbers to work with, numbers which we can actually calculate. So for example, I'm going to pick that y could be 4 and x could be 3. So using this method, with these examples, y squared would be 4 squared, which is 16, and x squared would be 3 squared, which is 9. So if y squared is 16, x squared equals 9, then y squared minus x squared would be 16 take away 9, and 16 take away 9 is 7. And the base, the final step is to square root what we got from y squared minus x squared. So in our case, the base would then be the square root of 7, which is not a whole number. So all you need to do is to pick different values of x and y and follow Noah's method and arrive at a square root which isn't going to be a whole number. If you square root a number that isn't a square number, you'll always get a decimal answer. And so this is working, which shows that sometimes it won't be a whole number, but like Noah shows us here, sometimes it will be. And so if sometimes it will and sometimes it won't be a whole number, we need to pick this middle option here. The method will sometimes give an answer which is a whole number. And the final question, question 28. We've got a coordinate grid and we're told it's the diagonal of a kite which has been given. So A to C is the diagonal of a kite. A is 0.15, C is for 0.31. The diagonals of the kite intersect at M. Now it says that M is the midpoint of AC. So the midpoint just means halfway along the line from A to C. So if A is here and C is here, then the midpoint of that line, the halfway point, will be here. So that's going to be M. So we can label M now. It now says that AM equals BM, and so another point of this kite is B, and so the distance from A to the midpoint will be the same as the distance from the midpoint to point B. And we're also told that BM to MD, the ratio of BM to MD, is going to be in the ratio of 1 to 2. We'll come to that in a second. What I want you to think about now is the properties of a kite. Now for any kite, the diagonals intersect at right angles. And so for any kites, the diagonals intersect at right angles. By intersect, I just mean they'll cross over at right angles. So what will happen as well, where the diagonals intersect, a kite will also have one line of symmetry. And so the diagonals will intersect halfway along one of the diagonals. And so, in a fancy way of putting it, the diagonals will cross so that one diagonal is the perpendicular bisector of the other. At any rate, right angle means 90 degrees, and the diagonals will cross at M. And so what we can do is measure 90 degrees from M. So we could either do the perpendicular bisector with a compass and pencil, but what I think would be easier is to use a protractor and to put the protractor over M and then measure a 90-degree angle from M. And so we put the middle of a protractor on top of point M, and then we measure from 0 degrees, and so we get the 0 line in line with either A or C, whichever we want to go for. So in this case I'm picking A, and then we measure from 0 counting up to 90. So 0, 10, 20, 30, 60, 70, 80, 90 degrees is here. So then we can move this away because we're done with it. In fact, I'll just delete it entirely. So what we know now is that the second diagonal will be a straight line in this direction. So A to C is one diagonal, the other diagonal will be along this other dotted line I've just drawn in. And so now it's just a case of thinking where the other points B and D could go. There's actually going to be two different options for this. And so one thing we're told, just going back to what I mentioned before, is from A to M is the same as the distance from B to M. And so if A to M is here, then BM will be the same distance, sorry, B will be the same distance away from M. And so B, for example, could well be this point here. And if that's the case, and this is B, we can start thinking about where point D will be. We're told that BM to MD is 1 to 2. And so the distance from M to D is going to be twice as long as the distance from B to M. Now from B to M, it's just 2 squares along. It's 2 squares up, sorry, 2 squares along and 1 square up. So if that's BM, MD will be 4 squares along, because double 2 squares is 4 squares. So 4 squares along, 2 squares up, tells us the point D would be here. And so, using that, if we just imagine we're drawing up the lines of a kite now, so the kite could look like this, from A to B, from B to C, and finally just joining up to D. And so point B, in this case, is this coordinate here. And so it's 0 along and 2 up. And so point B is 0 and 2. And point D is this one here, which is 6 along and 5 up. However, that's just one possible answer you may have got. We could actually have this kite reflected. Now, as long as BM is the same length, there is another possible location for B, which could be the same distance but the opposite side of M. And so for all we know, B could have been here, and D, instead of being 4 squares this way from M, D may have been 4 squares this side away from M. And so we could have said that D was here. And in that case, what we would have had is a triangle looking like this. Sorry, not a triangle, a kite. And then a line from A to D like this. So there's 2 possible kites. It could have been the blue kite or the red kite. And so if you put down this answer for B and D, that's absolutely fine. I will give you full marks. Or, for all we know, B could be the point here. B might be 4 and 4. And D, instead of being here, if we picked this red kite, D could be -2 and 1. And so this is one possible answer for B and D. In the brackets above, I've just put the second possible option for what B and D could be instead. So that's question 28 done, and therefore the whole paper looked at. So hope you've enjoyed listening to that and it's not been too dull for you. I do hope it's not too bad. Feel free to leave a comment or to subscribe and I'll get back to you as soon as I can. So thanks again for listening and hopefully you'll check out some more videos soon.